Hi, myself Vijay, founder of Sparks IT Solutions. Today I'm going to discuss about the field computer arithmetic. What is this field about? Where it is used? What are the use cases? And what could be the future computing? Before that, I'd like to give a little bit info about me. I'm a founder of Sparks IT Solutions. So when I was a kid, I was always passionate about. I'm still passionate about how the mathematics computed in a nature, in a computer or in a calculator watches. So this was a quest for me. So the little circle is me when I was around around when I was in second standard, something like that. So that drew me the quest so far. So during my studying in schools, undergrad, I was always asking this question myself: how it is done, how it is computed in nature, in computer or in calculator. I asked many professors, uh, many of my friends. Nobody answered question exactly how is that. So during my the graduation engineering at the end of a final semester, I came to know a very interesting um, field called a number theory. So this number theory is the initial starting point for to answer to my all questions so far. So I started to work on a number theory and then understand computers a bit more. So this the initial starting to understand the whole computer field starts from the number theory. So as you can see that there are about at least in my view there are three number systems. I would say one is the Indian number system. I can see you have a Tamil numbers here on the bottom. Devangiri is also Indian number system. It's a very old Indian language, Devangiri. So you can see 0 1 2 3 4 7 8 9 written in the same way. uh, Arabic. So Arabic number system is similar to our Hindu numbers. So it's almost resembles the same thing. And so after I think in around 500 BC, I might be wrong. Correct me if I'm wrong. So the European number system was invented, and the numbers are now you can see what you can see now computers or in a calculator on day to day. So you can see 0 to 9 on the top. So that was how it was started. So Romans were using this number system, as you can see in the bottom, the green color. So this number system, very I would say 1 to 9 was easy to remember, but after 10 it was so difficult. And moreover, this number system is not so used because whenever you do the arithmetic computation, the number representation becomes very long, and it's hard to compute all these Roman literals. So that this number system was, I would say, in other words, diminished very many years ago. So if you look at what are the day-to-day application is that, so we can use these numbers in a day-to-day life, maybe in a calculations or in accounting, you name it. There are a lot of applications. There are countless. Nowadays, it's a buzz. So we can use all the mathematical computing in a graphics. You can see the where whenever you shoot in a game, there is a sound, duk, 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 something like that sound, and lightning effect. And in artificial intelligence, where the neural networks are trained based on the calculus, machine learning. It's the same based on the calculus, high performance computing. Now you can see a lot of linear algebra equations. So, and the communications, it's also a calculus and some part of differential equations. So the graphics to communications or any scientific computing or climate modeling involves heavy math computations. You could name partial differential equations or combinatorics, discrete mathematics, or or you could say integrated calculus and so forth. So the applications lot, so there are countless. So these numbers are used in a lot of applications. Based on these numbers, equations were invented. So that is the truth behind the computer arithmetic. So these equations, now you can see a lot of scientists invented equations where on a paper. So the trend came in how to represent those equations in a computer or nowadays in smartwatches or mobile phones. So that is where the computer arithmetic field started. I think that this field was started in 1950s. So uh, so this is a very old field, computer arithmetic field. So the computer arithmetic stands for the computation of arithmetic in a computer. So that is where the computer arithmetic stands. So all the equations, whatever we see nowadays in a computer, so those comes under computer arithmetic. So this computer arithmetic um, uses a few number system, floating point numbers, logarithmic number systems, and these numbers are all represented in either a 0 or 1. So binary, you could say a binary. So in computer there are only two states. 0 stands for a ground, 1 stands for a voltage. So computer works on the switches. There are a lot of switches. Switch here is a transistor. So whenever you give a voltage, the switch will be closed, and then you get the output. Whenever you don't give the voltage, the switch will be open, then there is a 0. So simple, like this switch acts simple like our switches in a room, something like that. So this switch, but however this switch is very small. This is a transistor. Nowadays you can use transistor 7 nanometer technology or 10 nanometer, or I think people now are saying 3 nanometer technology. So the whole numbers in computers represented in the floating point numbers or logarithmic numbers. I don't go much detail into the what is the number system, the format. So this is the out of scope of this presentation, because this presentation is only about the introduction about computer arithmetic field and applications. So in future I may do a tutorial on floating point number system. So logarithmic numbers, you won't see logarithmic numbers in state-of-the-art processors now. So this is because the computational using logarithmic numbers is so complex, especially addition and multiplications. So that is not many companies operate for that. But the floating point numbers, now it is widely opted, and then it is a IEEE standard now. This is used in our laptops, smartphones, you name it, any digital gadget. So as the transistors are scaling down, so now the market demands comes to the performance. They now customers looking for higher performance. You might have seen nowadays the laptop become much lighter, much thinner, and then much heavy performance than was before. So that is because transistors are scaling down, and once the transistors scale down, then power becomes an issue, because the switching activities happen so much, is that in a small silicon die you can put lot of transistors, so the power becomes issue there. uh, and then once now the power becomes issue, then the cost and so forth related issue comes there. Most importantly, when you put a lot of transistors, the silicon area becomes much denser. In other words, chip becomes more dense. So people are thinking about how to overcome these challenges. So fortunately, there is a new number system called a POSIT number system, which overcomes all these challenges. POSIT number system is alternative to floating point number system, and This is more this number system can give you more accurate results than a floating point number system. There are not so much exceptions in the sense that you don't have overflow, underflow, not a number, something like that. You don't have that much in a float posit number system. So giving the posit number system has a large dynamic range. In other words, you can compute lot of arithmetic computations with the less data width. For example, a floating point for double precision floating point number system is a 64-bit. So the same accuracy of 64-bit can be represented in a posit number system using 32-bit. So we reduce the data width by half. So reducing the data width by half has a lot of advantages. In a silicon area, the silicon area is going to be half as well. The performance is going to be double, and then the power is going to be reduced as well, and the chip is going to be much cheaper because the silicon area is going to be less. So when the chip is going to be cheaper, or the chip is going to be cheaper, so then in the end it translates to the company's higher profit margins. So posit number system is I would say very uh, uh, it will address all the solutions to the problems what we are facing in the industry now. Uh, so considering this trend nowadays, what is happening, the future computing could be in cloud computing. In other words, whatever we do computation in a laptop or in a servers, that can be computed in a cloud. So the cloud is nothing but let's say a cluster of servers connected in a internet or in a network. Then to access those network, you need to have internet, and there are certain protocols one need to follow. So using those protocols, you can connect to the servers either using your laptop or mobile, and any digital gadget, compact digital gadget. So the computation or heavy math computing can be done on a server anywhere in the world, using this cloud computing. So the cloud computing brings a lot of advantages. So let's say in future, we may not need to have a motherboard in a laptop, complete motherboard where you have a graphics card, and then you have uh, memory card, and so forth. So in cloud computing, so let's say in future, using just only a network interface card, you just connect to the cloud, and then motherboard for that laptop or smartphone is there as an instance. So it's just like client laptop or uh, phone can act as a client. I think now the Chrome laptops are working in the same way. It's a cloud computer, something like that. And then the future is going to be IoT. In other words, most of the things, all the devices are going to connect through internet. In a network, it's the Internet of Things, IoT. I might have heard about this buzz. Most of the times, this word is used in smart cities. And I would say with the cloud computing, now the laptops or any digital gadget is going to be much cheaper, and for customers, is easy to adapt to any latest trends. Uh, yeah, that's it. If you have any questions, please get back to me, or any or you can get in touch through any social media networking sites. Thank you.